We have two intersecting lines. They form four angles. By the definition, 1 and 3 are vertical angles, 2 and 4 are vertical angles. We want to prove that angle 1 is congruent to angle 3. If we can prove that, then we use the exact same argument to prove that angles 2 and 4 are congruent. So we only have to do it once. And then we say, okay, now we understand that that works for the 1 and 3, so it'll work for 2 and 4. Now we want to think about the definitions of the angle pairs and types that we have been learning. And the first thing I want you to notice is if I cover up this part of our diagram, I see that angles 1 and 2 form a linear pair. The exterior sides are collinear. They form a straight angle. The interior ray or side, the one that's common between them, breaks that angle up into two angles. We see that they form a linear pair. So we write down angle 1 and angle 2 are a linear pair. And because they're a linear pair, the two angles, the measures together, form a straight angle, which means that angles 1 and 2 are supplementary. So angle 1 and angle 2 are supplementary. And by the definition of supplementary, the measure of angle 1 plus the measure of angle 2 is 180 degrees. Now we want to cover this part of the diagram, and we want to see the same thing about angles 2 and 3. They're a linear pair. So we write that down. Angle 2 and angle 3 are a linear pair. So angle 2 and angle 3 are supplementary. And from the definition of supplementary, the measure of angle 1 plus, the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. Now we bring in a little bit of algebra. But the idea is these two angles add up to 180 degrees, and those two angles add up to 180 degrees. And they share that common angle, angle 2. So let's write this down. The measure of angle 1 is 180 degrees minus the measure of angle 2. And the measure of angle 3 is 180 degrees minus the measure of angle 2. So let's look at this. These two angles add up to 180 degrees. These two angles add up to 180 degrees. This linear pair shares an angle with this linear pair. They both have angle 2 in common, and they both add up to the same thing. So that tells us, that's the implies symbol, that the measure of angle 1 is equal to the measure of angle 3. And by the definition of congruence, we say, therefore, angle 1 is congruent to angle 3, end of proof. So look at this argument. It's simply saying, look, we know what the measures are. We don't have to measure them exactly. We can't, because we're writing a generic proof for all situations of two intersecting lines. We don't want to measure anything. We don't want to put down a specific example. We just want to talk in general. Any two intersecting lines, we will have a linear pair here and a linear pair there, and they'll always be sharing this one angle in between them to form their linear pair, and therefore their angles are congruent. You can see the same argument for angles 2 and 4 being congruent. We say angle 2 and angle 3 form a linear pair. Angle 3 and angle 4 form a linear pair. They both share angle 3, so 2 and 4 have to be congruent. And we just already showed that 3 and 1 are congruent.